Hello everybody, I'm Dan. Welcome to my Java tutorial series. This tutorial is about generic functional interfaces, and of course that has to do with Lambda Expressions. I'm going to open up my web browser to my website, javacjava.com, select Begin, and I'm going to scroll all the way down here to Lambda and generic FI. FI is short for functional interface. Okay, so this tutorial is about Lambda Expressions generic functional interface tutorial. A functional interface can be generic with type parameters. If you are unfamiliar with generic type parameters and bounded types, then please watch my generic tutorials to familiarize yourself with the concepts. In this tutorial, I will introduce you to the powerful things you can accomplish when combining generics with Lambda expressions. So an example of a generic functional interface looks like this, right? You got your interface keyword, and then you've got the name of your interface. And then inside of your diamond syntax, you'll have, basically the type variable, right? And then in your interface body here, you'll have your single, one and only abstract method. And this is, of course, implicitly abstract because this is an interface. You could also type in abstract in front of that, won't matter, right? So in this particular case here, I've got mystery method. And it will take a generic type T, right? Variable type variable, I should say, right? And then parameter variable x, and then it'll return an int data type. Okay, so instead of something, for example, like right here, like double x or int x or char x or something like that, right? Or string x or who knows, whatever, right? You can use the generics here. Okay. Okay, so you can also have a generic return types for your abstract method with a generic functional interface. All right, so in order to do so, we got basically the same declaration here, only I'll have like t, comma, v, and these are just going to be type variables there, right? So in this particular case, t will be the return type, mystery method is the method name, and the parameter will be of type v, generic type v, and then of course the parameter name here, x, and of course this is implicitly abstract. All right, so I'm going to run you through some code here. This may look a little confusing there. Let's go ahead and just come down here and go through this stuff, and I'll show you. It really is pretty cool what you can do with this here. So we'll highlight all this stuff. Control C to copy, or right click and select copy. I'm going to move my browser off screen, and I'm going to open up my command prompt. Now I have a shortcut to the command prompt on my desktop here, but if you don't, you can create one really fast by right clicking and selecting new shortcut. CMD next and finish. It's just that easy. First thing we do when we open this up, we're going to type in javac, which is a Java compiler command. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java development kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen. CD space /. CD is short for change directory, and / tells it to go to the root. We'll make a directory here called Java. Now I already have that folder, but if you don't, it'll go ahead and create one for you. I'm going to change directories to the Java folder. I'm going to make another directory here, and I'm just going to call this Lambda generic FI functional interface. We'll just go a little shorter on that. Change directories to that, and notepad. Lambda generic fi.java will be the name of my source code file, also known as a compilation unit. All right, let's go ahead and Control V to paste all this stuff in here and come up here and save this. All right, so in this class, Lambda generic FI, I've got the main method entry point here. And I've got just a single interface down here, functional interface, right? And it's a generic functional interface. And I've got two type variable parameters here, the T and the A. So T will be the return type here, variable. And then I've got this one parameter method here. And then it'll be of generic type A, and param1 will be the name on that. Okay. To start off with, I'm creating an integer array, and it will have 20 elements, and then I'm just populating that with a simple for statement, right? And I equals 0, I is less than array.length, I plus, and then setting each one of these array elements equal to whatever the value of I is. And by the way, auto boxing will actually make, integer objects out of whatever these primitive types are there, right? And if you're not familiar with auto boxing, if that doesn't make any sense, like you're like, oh wow, that must have something to do with like the transformers or something, right? Then no, you need to watch my tutorial on auto boxing and auto unboxing there. So, okay, so that just builds a simple integer object array, right? With the values 0 through 19 in it, basically, right? Because there's 20 elements starting at 0. So, okay, now let's come down here to declaring the functional interface reference variable numbers, right? And so inside of the diamond syntax or the chevrons, you know, whatever you want to call it there, I'm specifying Boolean here, right? Now, when we come down here to the functional interface, Boolean will be our return type for this, for the one parameter method here, okay? And for the second type variable parameter here, it will be an integer, right? So when we come down here to the functional interface, this will be an integer, and that's an integer wrapper class, right? Type for the parameter variable there. Okay, now let's come to our Lambda expression here. So y is just a basic old variable for the Lambda expression, doesn't really mean much there. And then we got our Lambda operator, because this is basically what's going to come into the this right here, okay? That's going to be the argument that's being passed, and then this will receive it as a parameter right here. All right, and then just a simple expression for this Lambda expression. Y mod 2, which is a modulus operator, basically divide it by 2, and if that equals 0, right, then this is a expression that'll evaluate to either true or false, right? It'll either be equal to 0 or it'll not be equal to 0, right? So, for example, 4 mod 2, 4 divided by 2, the remainder is 0, right? 5 divided by 2, the remainder is 1. So basically I'm going to be pulling out only the even numbers out of this array here based on this particular Lambda expression here, okay? So let's loop through using an enhanced for loop, right? I'm going to declare an integer type temp here, right? And then we're going to iterate through the I array up here. So if numbers, and then invoking the one parameter here, which is our method from the functional interface here, right? And that's going to return back a Boolean type, right? And Boolean, as well as you know, all the primitive integer wrapper classes will autobox and unautobox automatically, right? So a primitive value, primitive Boolean, right? True, lowercase true, that is, right? Will evaluate back from a Boolean wrapper there. So just if you're not familiar with the wrapper classes too, you're going to want to watch my primitive wrapper classes there, as well as the auto unboxing and everything like that. I'm building on a lot of concepts from prior tutorials in this particular one here. So, but basically we're going to be passing the value of temp first of all, right? And so if you're thinking of in the actual terms of the array, in the first element there, it's just going to have a 0, right? And so 0 divided by 2 is still going to be equal to 0, so that's going to return true, and we're just going to do use the print method, not the print line method, just the print method to display whatever the current value is. In this case would be 0 and then plus a space. So we'll end up building this whole entire string here. All right, so what I'm going to do is then I'm going to display a line feed after that. I'm going to come up here and compile this and run it here real quick before we go into too much here, so I can go a little line by line. So CLS, and then Java C, compile this, Java to run it. Okay, so on the first printout there, right, we get all of the even numbers there, right, 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18, right? And so and then basically I display a line here. Now the next thing I'm going to do is I'm going to use the reference variable, right? And it'll still be Boolean and integer is what it's going to take, right? Boolean being our return value from the, the return value from the one parameter here, right? And then A being the integer type that's going to be the parameter value, okay? All right. So I'm just going to modify the Lambda expression on the fly, right? We'll be taking in y, of course, will be the parameter, right? And then we're just going to check, see if y mod 2 is not equal to 0. So that'll return back. This is an expression that will return either true or false. So if it's not equal to 0, it will return true. So that'll basically give us all of our odd numbers here, right? And then I'm just going to loop through that same array, invoking the one parameters method and passing each different element through it, right? And if that particular element, that should actually be tabbed out there just a little bit, make that a little bit more readable there. But basically, if this is an odd number, it'll go ahead and display it to the console, right? Okay, just come up here, recompile and clear the screen, rerun it, right? So that is what we end up right there after, you know, basically doing the Lambda expression right on the fly with that. Okay, now we've got the functional interface here, and that's all pretty simple and straightforward there, right? It's kind of cool. You know, you can specify whatever your return type is, and then you know what's going to be your parameter type for whatever you choose to do with this one parameter method here. Okay. All right. So let's come down to the next thing that I want to demonstrate here. So I am declaring a new reference variable called evenString, and it's a functional interface type. And now you'll notice that I want to return back a string and pass in an integer array. All right, so I'm not creating a new functional interface or anything like that. Right, this is still the same interface. I am now specifying generic. I want some new generic stuff going on here. So I want to return back a string. So t, right, being the first type variable parameter, is now going to be a string, right? One parameter, and a is actually going to be an integer array that I'm going to be passing in as the parameter. Okay. All right. So now to the Lambda expression here, and this is a block expression that I'm setting up here. So I thought I'd demonstrate it kind of both with like a single expression and one with a block expression here. So we're going to be basically the parameter argument, whatever you want here, is going to be passed in right here, and it is going to be an actual integer array. All right. Excuse me, still battling this cold here. Okay, so the first thing inside of the Lambda block body here. Hold on. Had to get some water there. That was getting a coughing fit or something. Okay, so first thing inside of the Lambda block body here, I'm declaring a string variable s and setting equal to nothing basically there. And then, of course, because x is going to be an integer array here, right? I'm just going to use an enhanced for loop to iterate through the x integer array here, right? Setting an integer, basically reference variable temp, right? And then I'm checking to see if temp mod 2 equals to 0. If it is, then I'll go ahead and just say, you know, s equals basically s plus temp plus then a space, right? So I'm going to build a string here of all the even numbers, and then I'm going to return that string, okay? And then I'm simply going to put my spacing around here just a little bit there. I'm going to invoke the printline method, and then I'm going to do evenString and then invoke one parameter with the iArray up here, right? And that's my original array up here. So I'll be passing in an integer array to the one parameter method and getting back a string that I'm going to, oh, wait, I'm up here on evenString there, right? So, okay, so evenString, passing in the iArray there, invoking one parameter, and we're getting back a string here that basically will display to the console there, right? So you can see string is going to be a return type. My parameter type for my method down here in my functional interface is going to be an integer array. There's my string type right there, right? So that's basically the way that works. So let's just come up here, save, let's clear our screen, recompile. I made just a couple little line corrections there just to make it a little bit more readable. But anyway, so you can see here's where we're at. And this is the string that's displayed to the console right there. Same exact evenString is doing it this way up here. All right? Okay. So that's it right there. Okay, we're getting back a string that we built inside of our Lambda expression inside the Lambda body here. All right, now let's do our odd string here. And what I'm going to do is, I could have used the even string instead of redeclaring this, but I'm like, I want my reference variable to be named odd string. So same functional interface, right? And we're getting back a string return type, right? I'm passing it an integer array into the one parameter there. And same exact thing, only I'm checking here temp mod 2 is not equal to 0, and that will go ahead and keep building this string, until we're all done there, done iterating through the integer array, right? That's coming in basically as the parameter right in through here, okay? And that'll return back our string of all our odd numbers right there, and you can see that's what we get, the same exact thing going on right here. Okay, so at this point, there's a couple things. I'm gonna kind of pop right into my final thoughts, but I'm gonna leave this up here because I'm gonna go over just a little bit more here. Actually, one more thing before we go over this. Right now, we've done a couple of different things here with just this really simple abstract method called one parameter, right? And it's not designed to do anything specific. It takes a generic parameter and has a generic return type. So the possibilities on what we can do with this are really kind of almost like endless, right? So you can imagine, what if we had another interface here, right? One thing about a method is you can only have one particular return type, right? But let's say, for example, we created another like functional interface, right? Just call this functional interface 2. Right, and passed it in another one here, right? And we called this method called like 2 parameter here, and b, and then param 2, right? Now you can start to see like, oh wow, we could kind of expand this out and have a functional interface 2 and a 3, and wow, I mean, depending on how many parameters there, we can only have one return type. Obviously, that's just like a golden rule with methods there. So, but with relatively like a handful of them, you could almost do just about anything. It's just that powerful, with generics and combining generics and the other there. So if you're looking at this and like, the wheel in your head is spinning, going, oh, okay, wow, might be able to do some, just wow, okay, any return type here, right? As long as it's an object. Any objects can be passed in, right? And arrays of objects can be passed in, as I showed you there too as well, right? Then, you can really expand this out. So with that being said, I'll just come up here and save this, compile it, run it one more time. Oh, wait. Run it one more, clear our screen here, Java, there we go. Run it one more time. With that being said, there's a couple different possibilities after this particular tutorial right here. So I'm just going to go into my final thoughts here. So I'm going to leave that up here. But after watching this tutorial, are you left with this sense of confusion or frustration? If so, that's normal. You're learning. You'll need to review my generics and Lambda tutorials until each concept makes complete sense. Now, sometimes you may want to step away for a day and then come back to let new concepts sink in. But, however, if this tutorial makes 100% complete sense and has you thinking about the power of combining generics with Lambda expressions, well, then you can rest assured that you're ready to tackle even more advanced concepts. I was thinking that, at this point in my tutorials, I plan on spending some time filling in the gaps on many things that I've skipped over or overlooked throughout my tutorial series thus far. But one of my goals was to cover some basics on generics and Lambda expressions prior to teaching collection, list, and array list related stuff. I mean, I see a lot of people who delve into those things, going into array list before someone even has a clue what generics are. So they're looking at the syntax and, you can understand enough about it, but it really helps to know what generics are, at least at like some foundational level. So I think I've kind of laid out foundation there. So anyway, that concludes this tutorial. Go ahead and close out of this. Thanks for watching.